so we will be starting with chapter 11, trigonometric ratios of book D2 mathematics syllabus D. So here it's a right angle triangle, okay, ABC. So 90 degree making at C, angle C is 90 degree here. So the side opposite the 90 degree will be the longest side, which is the hypotenuse, and the second angle is given on A. So the criteria for a side to become an adjacent is that two angles lies on that side. So the side will be called the adjacent or the base. So the remaining side will be called the opposite. So first you have to spot on the side which is the hypotenuse, which is always opposite the 90 degree, and the side making or the line making the two angles, the side will be called, that side will be called the adjacent or the base. Okay, so moving forward, in this triangle, if angle C equals 90 degree, then the sine, okay, sine of angle A, okay, if you have to find angle A or one of opposite and hypotenuse, so sine A is given as opposite over hypotenuse, or sine of angle A is given as opposite over hypotenuse, and the cosine of angle A is cos A, or cosine of angle A equals adjacent over hypotenuse, and the tangent of angle A or tan A equals opposite over adjacent. So the easy way to remember all these three ratios is this. Okay, what is this? So what does this mean? Sine of an angle equals opposite over hypotenuse. Sine of an angle equals opposite over hypotenuse. What about this? Cos of an angle or cosine of an angle equals adjacent over hypotenuse. Okay, and the tangent or tan of an angle equals opposite over adjacent. So this is an easy way to memorize these trigonometric ratios related to a right angle triangle. So okay, so now we will be doing question number 6 of review exercise 11. So in this triangle ABC, AB equals 13.2, BC equals 6.9, and angle ACB equals 90 degree. ACB, okay. H lies on AC. Point H lies on AC such that angle BHC equals 46. Angle BHC equals 46 degree. We have to find, in part 1, we have to find angle ABH. So what is angle ABH? ABH. So AB. This is the angle we are required to find in part 1. Okay, so what is the first step to find this angle? So what is the thing you can find first? Is this angle HBC, correct? So what will be the criteria to find angle ABH? Will be this total angle, which will be ABC, angle ABC, minus this angle, which will be angle HBC. So we can write this angle ABC, which will be the total angle, which is angle ABC, minus angle HBC. This part will give you this smaller angle. So you can write this down. Angle ABH will be equal to angle ABC minus angle HBC. Okay. So angle HBC is easy to find. Easy to find this angle. So angle HBC equals, because the sum of triangle is 180 degrees, so we can minus the rest of these two triangles from 180 degrees. So 180 minus 90 minus 46. Okay, this will be equal to 44 degrees. So angle HBC was 44. So the next step where we are trying to find angle ABH. We have already found angle HBC, which is coming at 44 degrees. So the next step will be to find this angle A. Why this angle A? Because once we have this angle A, okay, we can find this whole angle B. Okay, how? 180, the sum of triangle, minus these two angles will give you this whole angle B. Okay, so once we have this whole angle B, that whole angle minus 44 degree will give you this small angle. So this is how we will find angle ABH. So first trying to find angle A. So how to find angle A? Because two of the angles lie on this line AC. So this is our adjacent. The side opposite the 90 degree will be our hypotenuse, and the remaining side which is left will be the opposite. So we will take two of the sides which are given. Two of the sides which we have here is AB and BC, which is our hypotenuse and opposite. Okay, if we rewrite these three ratios, okay, in the form I told you earlier, which is very easy to memorize. So here if we see, we have the opposite and hypotenuse. Okay, which one of these three we can apply? Opposite and hypotenuse is in the sine of an angle. So sine of angle A to be equal to the opposite over hypotenuse. Opposite over hypotenuse. 6.9 over 13.2. Okay, so angle A will be, this sign shifted here will become sine inverse of 6.9 over 13.2. Okay, so if you put this in the calculator, you will be getting 31.5 degrees as angle A. Okay, so this is coming as 31.5 degrees. So now it's easy to find this whole angle B. So 180 minus 90 minus this will give you this whole angle B, which is angle ABC. So angle ABC equals 180 minus 90 minus 31.5, which will be so if you put this into the calculator, you will be getting 58.5 degrees. So this whole angle is 58.5 degrees. So now it's very easy to find this angle ABH. So how we find this? This whole angle we just got for 58.5 minus this 44. Okay, so angle ABH equals angle ABC minus angle HBC. Angle ABC minus angle HBC. So which will be 58.5 degrees minus 44 degrees, which will give you 14.5 degrees as your answer. So this is the answer to part 1. In the second part, we are required to find the length of AH. So how to find the length of AH will be this whole length AC, minus the length of HC. So AC minus HC will give you AH. So we can write this down. So AH equals AC minus HC. So we don't have any of these two lengths, so we can find it one by one. So how to find the length of AC? The length of AC is very easy to find. How? Using Pythagoras theorem. Because we have, if we consider this whole, the larger triangle ABC, we have the hypotenuse and the opposite both. So we can try to find the third side. So this is the hypotenuse, which is the longest side. The square of this minus the square of this, then square root the answer. Okay. So AC square will be this square minus the square of this side. Okay, so if you use a calculator, you will be getting 1 square root of 126.63. Okay, we are getting 126.63 here. So removing the square and square rooting this side. So the answer to this, the length of AC will be, you square root this, you will be getting AC as 11.25 meter. So the unit here is meter, not centimeter. Okay, so this is the length of AC. Now we'll find the length of HC. So we have to consider this smaller triangle. Small triangle. We are finding HC now. So we have many ways to find this. Either we can take this side as adjacent, because we have two angles on this side as well and two angles on this side as well. So it is upon us that which side should be the adjacent, either this side or this side. Okay, so I'll be considering this side as our adjacent, this HC as our adjacent. So you have the opposite here. Of course, this HB will be the hypotenuse. This is adjacent because we are considering this as our adjacent. This will be the opposite. So which ratio, which one of these three ratios, sine, cosine and tan, will you apply when you have opposite and adjacent? So coming back to this opposite and adjacent. So which one you have to apply? You have to apply tan. Thus tan equals tan of angle H here, because we are taking this as adjacent. So tan of angle H, which is 46 degrees, equal opposite over adjacent. So opposite is 6.9 and the adjacent will be HC. So HC, you will change the places of these two. So HC will be equal to 6.9 over 1046. So HC will be coming as, if you put this into the calculator, your answer will be 6.66 meters. Sorry, 6.66 meters. So now we have AC as well as HC. So the final part of this question will be to subtract 6.66 from 11.25. So AH equals 11.25 minus 6.66. So you are getting the length of AHS 4.59 meters. So this is your answer to part 2. Now moving on to question 7 of review exercise 11. So we have a triangle here, or the figure which shows a triangle PQR. PQR where PQ equals 50 cm, K lies on QR. okay, such that angle QEK equals 30 degrees. QEK equals 30 degrees and angle RPK equals 46 degrees. RPK equals 46 degrees. Find the length of QK. We have to find this. So this will be easy because this here angle K is a 90 degree angle. So here we can apply the same. So to find QK. So which one of these three ratios will be applying here? So we have to see, we have to find this, and we are given this. So we are given the hypotenuse, and this thing, this line or this side will be our adjacent, correct? Because we have two angles on this side. So this is adjacent, this is the hypotenuse here, and this will be our opposite. So we are required to find this, and we are given this. So what is applied when we have opposite and hypotenuse? Sine is applied. Okay, sine of angle, which is given sine 30 equals opposite over hypotenuse, QK over 50. Okay, so these two will be multiplying together. 50 sine 30, correct? 50 multiplied by sine 30. So if you use a calculator here, you will be getting QK as 25 centimeters. Okay, so now we are required to find QR in part 2. So to find QR, we have to, because this is a non-right angle triangle, so we have to find these two sides separately. So you have QK already with you, okay, in part 1, which is 25. So you just have to find KR. So in order to find KR, you should have this length PK. Okay, why? Because if you consider this triangle, you only have one angle here, no side. So in order to find this KR, you should at least have one side, either the hypotenuse, the adjacent, or the opposite. You don't have any of the three sides, but only one angle. So you will be finding PK first. So how to find PK? First you will write how to get QR. So QR will be adding QK and KR. QR equals QK plus KR. Okay. So finding this PK, the length of PK first. So you got this side as 25 cm in the first part. So just we will be applying the Pythagoras theorem to find the third side, because it's a right angle triangle. So this is the hypotenuse. So this 50 square will be equal to this square plus this square. So this side will be subtracted from the square of this side will be subtracted from the hypotenuse, correct? So PK square equals the hypotenuse square minus the opposite square. So QK square. So this will be 50 square minus 25 square, which will give you. Okay, so 50 square minus 25 square is giving you 1875. So now remove the square there, you just square root this. So your answer, the length of PK will be 43.6 centimeter. Okay, so this will be the length of PK is 43.3 centimeter. Okay, so now we can find KR because we have an angle. We have an angle here and a side here. Of course, we can find the third angle, but there will be, as I told you earlier, there are many ways to find a side or an angle when applying these three ratios. So you have two angles on this line PK. So this will be our adjacent, and we have to find KR. Of course, the length of PR will be the hypotenuse because it's opposite this 90 degrees. So this remaining thing will be the opposite. Okay. So we have to find this, and we are given the adjacent. So what is applied when we have opposite and adjacent? We will apply tan or tangent. So tan of angle which is given 46 as 46 equals opposite KR over adjacent which is 43.3. If we just find here the length of PK 43. So these two will be multiplied together. So 43.3 tan 46. So KR, if you put this into the calculator, you will be getting 44.8 centimeter. Okay, so moving to the final part of this question. So now you have KR here. We have already found out the length of QK in the first part. So just add in these two lengths now. So QR equals QK plus KR. QK was 25 plus KR is 44.8. So QR, the final answer to part 2, the length of QR will be 69.8 centimeter. So that is it.